So this is a good one for unfamiliar because that's a bit of an issue. Hopefully we're just going, hey, wow, if it was an x squared and a y squared and some sort of number, then that's a circle. So we're thinking that's sort of like a circle, but it's not a circle because of that too. And that's about where we can stop. It doesn't matter that you don't really know that that's an ellipse. And even if you did know that it's an ellipse, is it an ellipse like that or is it an ellipse like that? Irrelevant. We don't really need to know, so let's not get too hung up on it. Let's go. Where we go sideways. There we go. Oh, and that's the worst looking ellipse ever. Let's try that again. Still not great, but anyway. So you can see that we've got a rectangle formed by it. So I'm thinking, depending on where this point is, if that's the point xy, then x is there and y is there. So x times y is that area. So we're looking at maximising area. So clearly we want a function area equals length width, which is xy. What's y? So we want to differentiate it, set it equal to 0, but we've got some work to do before that because we can't differentiate x and y. We want to go in there and go, well, what's y? I'll squeeze it somewhere. Y squared equals 2 minus 2x squared. So y is just going to be the square root of that thing there. So a equals x. Actually, xy was just that little square, wasn't it? So the area of the whole thing will be 4xy. And y is 2 minus 2x squared. As soon as you get there, easy pickings. We just got to differentiate that and set that equal to 0. We have no calculator, so I guess we're thinking of uv, where u is. And hopefully you're thinking that we're home and hosed here, because that's just a product rule. Do not rush yourself. Get your scrap piece of paper. So it's going to be the chain rule. So it's going to be a half multiplied by the derivative of what's in there, which is minus 4x. And then it's going to be that bracket to the a half minus 1, which is minus a half. The 2 and the 4 will cancel, so it's minus 2x on root. So don't stuff it up there. Okay, so it's going to be vu dash plus uv dash, and that will be v u dash plus u v dash. Clearly I'm struggling with room, but you're going to have absolutely buckets of pages to do this in. So let's just think about that. That's going to be minus 8x squared minus 8x squared. Let's just move that minus again. Minus. Okay, we're adding fractions, so I want to multiply top and bottom by root 2 minus 2x squared. These square roots will just undo themselves. So really all I want to do is undo that square root. And we've got the bracket. We do have a common denominator. And that's going to be 8 minus 8x squared, expanding that, and then I've got to subtract a minus another minus 8x squared. So that's going to be 8 minus 16x squared on the big square root. Okay, yes, it's messy, whatever. And we're going to set that equal to 0. So by our null factor law, we want that to equal 0. Yes, I don't have any room there. Let's just scribble some of that working out. Because surely that's easy by now. You can do that. That's just a product rule. So let's just do a different colour. So we've got 8 minus 16x squared equals 0. So x squared will be a half, x will be 1 on root 2. So the question asks for the maximum area. So the area happens where x is 1 on root 2. And there's my area function there. So I'm going to go 4 times 1 on root 2 multiplied by 2 minus 2 times x squared. Well, if x is 1 on root 2, then x squared is a half. So 2 on 2 cancels. 2 minus 1 is 1. So that whole square root is just 1. So I've got the answer 4 on root 2. Let's rationalise. What's that? So that's going to be 4 root 2 on 2, which is our answer. 2 root 2. Hopefully by then, the beginning of that question really is all that you need a bit of a hand with. The rest is just manual product rule, set it equal to 0 and find the area.